Welcome to the Slop Temple. We pray this video helps.
You start by preparing a controlled environment and getting credentials in place. Create a virtualenv, activate it, and install speech recognition, PyTorch 3, transformers, and requests so your code has all core capabilities. Next, configure your API keys as environment variables. This keeps secrets safe and portable. Once done, scaffold a minimal main. Py that imports audio I/O and a simple intent handler. This gives you a runnable loop to iterate on immediately, rather than delaying until later. You now wire audio, NLP, and TTS together so the assistant can sense and respond. First, implement a streaming microphone reader that performs basic noise reduction and yields short frames for low latency. Then send chunks to your speech-to-text. Once you have text, parse intents with a rule-based fallback and an LLM model for complex queries. Finally, synthesize the chosen response with PyTorch 3 for offline use or a cloud TTS for more natural audio, making you finish by hardening features and preparing deployment so the assistant is reliable and maintainable. Implement short-term context storage and dialog state to manage follow-ups. Then package the app in Docker and expose a REST or WebSocket interface secured with tokens. Include logging for audio, transcripts, and model decisions to trace behavior. If responses are wrong, replay logged audio and compare transcripts versus model outputs to isolate whether the issue is recognition, intent parsing, or generation. Then adjust thresholds or prompts accordingly.
Thanks for watching. Consider subscribing if we helped you.